Since word problems are challenging, let's take a look at some of them. For problem 5, pause it if you need to read it and look ahead. And it's always a mistake to just let the teacher or a classmate do all the work. But if we're told to solve the formula for height, and if you look at the picture on the right, here's your formula. So it's kind of like you got to just look at all the nonsense and filter out all that you're interested in. So if we want h to be by itself, and the formula is v equals pi r squared h, there's pi, there's r squared, there's v, but v is on the other side, so we're not so worried about that. But I know that I could do pi divided by pi to get 1. I also know I could do r squared divided by r squared to get 1. So even though it might seem kind of strange, it's best to, in one single step, divide that whole entire right side by pi r squared. Anything you do over there would also have to happen on the left, so there's pi r squared. So v over pi r squared, the pi's cancel out on the right, the r squareds cancel out, and the only thing you have left is h. There's no need to rewrite this like I'm doing. I'm just showing this in case somebody's confused. So there's v over pi r squared equals h, and then you're going to rewrite it as h equals v over pi r squared. So it really doesn't matter that this is a soap company. It's just, there's your cylinder. It's supposedly going to hold new liquid soap, and there's your formula. And here we did get the h solved for so that it's on the left. What this means is that for part B, we can set this up to where we use the formula. That's why these problems are designed the way they are, is so that our new inputs are volume and radius, and then our output is going to be h. So let's see, what's the height of a container if the volume is 56.52 cubic inches? So just for the heck of it, I could write my units just so we can see what happens. There's IN3, and the radius is 1.5 inches. So here's pi times 1.5 squared. Now I don't have a calculator like you might have in front of me, but if I did type in 56.52 and I did want to divide that by pi, I couldn't just type 3.14 times 1.5 squared. And the reason I can't is because that would not be treating this like the whole thing was getting divided. So if I do that again, you have to put the denominator in parentheses. Once I do that, I'll get 8. Now, I totally rounded pi. This would not be exact. So because of that, I'm going to use this and say 8.0. And my radius would have had inches squared. So 2 of these inches cancel out, and I'm left with just 1 inch up top. So there's my 8 inches. And if you're confident with that also, but if you did all your work correctly, what would the height be measured in based on this problem? Just inches. And so you do need to show your units there. Since I said I'd like to go through 3 or so problems, there's number 5. And move my paper up for number 6. So good chance that you can jump around and kind of figure out where we're at, should you want to maybe see something further ahead, like if that problem wasn't necessary for you to watch. Helpful to hear after I went through the whole thing, right? Scott found a rare comic book in an online auction site priced at 35 Australian dollars. And if you look at this, maybe I can put like 35 AU dollars or something like that to make it clear that we're not talking about 35 American dollars. And then the other fact they give us is that 1 American dollar is equal to 1.09 Australian dollars. Find the comic book's cost in United States dollars. So we're given $35 Australian, and we need to multiply that. Well, the goal is that we're left just with American dollars. So I set up my conversion, And I know that if I want these to cancel out, I have to have Australian dollars in the denominator and American dollars up top. So I filled in the dollar sign, and that's what we want to know. So either my number 1.09 goes here or here, but because the ratio or the rate is $1.09 Australian for every $1 American, that's what we would do. We always scan through our numerator. 35 times 1 is just 35. We scan through our denominators, and since multiplying by 1 is unnecessary, I'm just going to do this. And my new cost is going to be approximately $32.11. We also can look at our units, scan through the numerators. We're good to go. These are American dollars. And if we think about it, we could say, well, does this make sense? If I go from 35 Australian dollars, and if in this case the dollar can buy more, to me it makes sense that that number would be less. Let's get this repositioned, and then we'll look at number 17. Like it just looks freaky to so many people. So physics. The acceleration is the measurement of how fast a velocity is changing. The formula for acceleration is, now I'm not writing A as in part A of this two-part question. I'm just stripping the formula from the equation because usually that's a little bit more approachable. A represents the acceleration rate. V sub f is the final velocity, V sub I is the initial velocity, and t the time. So we're told to solve the formula for this one right there. That means that we need to get Vf by itself. Well, anytime something's being divided, we need to fix that. So now I actually am moving on to part A, and because of that, I'll go ahead and sneak an A up there. I'm angling my t up because my goal is to multiply these and they cancel. I really should show parentheses to be accurate. And now I'm left with AT on the left is equal to VF minus VI, so V sub F, V sub I. And I'm closer to having V sub F by itself, but I need to add initial velocity to the left side. These go away, so the only thing I'll have on the right side is V sub F, which I write on the left to make it clear. And here's AT plus V sub I. We're told to figure out what is the final velocity of a runner who is accelerating at 2 feet per second. So here's V sub F. They're telling you that they're accelerating at 2 feet per second for 3 seconds, 2 feet per second squared, excuse me, with an initial velocity of 4 feet per second. Scan through this. I look at my units. Here's feet and seconds. Here's seconds. Here's feet. It's not like they've thrown contradictory units at us. So when I go and I plug this in, 6 plus 4, and then I'm going to say 10 feet per second because we are talking about velocity. And that's how you would do 3 of these problems. Don't forget, you could rewatch it. You can ask me questions. Hopefully it went okay.